Welcome back to class. I'm glad to see everyone here today. We are going to cover section 2.4, percent change during class, but we always want to start every class by answering questions that you've got on any of your homework that you've done from the last class session. So where are we going to begin to answer questions about homework? How'd it go, Karen? It went good?
I got a question.
Quincy.
Number 15.
Okay. We're in section 2.3.
Yes.
All right. Let me get my book open. Okay. Do we just want to talk about it in general?
No, I wanted to find out. I kept getting sevens repeating. And I don't understand how they got 6-3, 6-3, 6-3, 6.
Okay. It says Susan has $35,000 invested in bonds. And is that another 45% in stocks? What is the total amount invested? Is that the question? And did you read that as another instead of other? 45% another?
No, I didn't.
I think I'm reading. Does anyone agree that that might have? I think the word there is confusing. That's right. It says Susan has $35,000 invested in bonds.
I think it is the other.
And another 45% in stocks.
The 35,000 was 55%. Yeah.
Okay. Okay. She has money invested in two places. She has, and I was not reading it that way to begin with. I do think that question probably needs some clarification. It says her money, they're reading the question a little different than I did. This is the first edition of this book, and it is an excellent book. But I think there will be some things like that that we'll discuss with the author and make sure we kind of clarify. But yeah, I think that's exactly what, and you're getting the answer that's in the book. It's saying her money was divided into two pieces. 55% of it was invested in bonds, and 45% was invested in stocks. And the amount that the 55% represents is $35,000. And that's not the way I read it the first time I read it either. So we're saying that 35% is, $35,000 represents 55%, and it wants to know the total amount. So we've got the part, and we're looking for the base. So we're going R over 100 equal P over B. We're looking for total amount. We're looking for B. We have the part. The part is 35,000. The percent or the rate that represents the part is 55. If we take that and cross multiply, I'm going to move this down here. I'm going to get 55 times B equal 35,000 times 100. Is it okay if I use those dots to represent multiplication? Okay. Then I'm going to divide by 55, divide by 55. That will give me B equal, and if I get out my calculator, I've got 35,000 times 100 divided by 55. When I do that, I got 636, and probably we're going to call that 36 cents. Did that answer your question, Quincy?
Yes, it did.
Okay. Someone else had a question back there. You had the same question, and you read it, and we're probably getting the same answer that Quincy got. Okay. That's one of those that we will maybe make a note that we need to clarify in the next printing. Actually, they're going to do another edition probably in another year. Great. Who's got another question? So the homework went all right? Once we went through the class notes, you could go home and do your homework. Our goal is that you could always go home and do your homework. Ready to talk about 2.4 then? Today's topic is percent change. When we have a basic percent problem and there is change, one of two things is going on. It's either going up, increasing, or the percent is going down, decreasing. If we were looking at a typical college campus and we had more students in the spring than we did in the fall semester, we would say that enrollment had increased by a certain percentage. Likewise, and we will talk about retailing later on, but if we go shopping and something has been marked down, then it has a percent of decrease, and the percent is going down. In these problems, just like in the problems that we did in our last class section, the original amount is always represented by, like the base, the beginning, and we call it 100%. You know how the base was represented by the 100 in our proportion. We are going to solve all these problems with proportions. We're going to set them up a little differently to begin with, but we're going to use the proportions that we used in our work in 2-3 to solve every one of these problems. We need to realize that an increase problem is always the original percent or the original amount plus an increase equals a new value. Likewise, in a decrease problem, we are subtracting. The base is always the original amount. We talked about a building in 2-3 that we bought for $425,000, and later we sold it for $450,000. What we used as the base was the original, the starting point, the $425,000. And what you're going to need when we set each one of these up is to figure out what the base is and realize that that goes by the word old. Original. Okay? We are going to use a new model. It's here on your handout when we work with percent increases and percent decreases. We're always going to begin by writing the word old, change, new right down the middle of our paper. Does everyone see where we are on the notes? The notes are titled 2.4 on the top. They should follow directly after the pages that we finished in class in our last session, and that'll help you stay where we are. Did you get it? When we have a problem where we're talking about increase, the change is add. When we're talking about a problem where the percent has been decreased, we're going to subtract, and you're going to need to keep track of whether we're dealing with problems where things are going up or things are going down. Okay? All right? What we're going to do is on one side of this model, we're going to write the percentages, and on the other side of the model, we are going to write the dollar amounts. I'm going to switch to a different page. Did you see that? I just wrote that one by hand. We're always going to begin by setting it up to look like that. We're going to write old, change, new. You're going to do all of your homework writing old, change, new down the middle when these are percent increase and percent decrease problems. You're going to put the percents on one side. I tend to always put the percents on the left side. You put the value or the money on the right side. You can do it the other way. I'm not very creative. I tend to do things the same way every time. You'll find as we read these problems, when we put the numbers into the model, you'll have no problem then working them. Okay? Up the example, let's read it together. We're going to set it up. Got to see if I'm on the paper. There we go. It said there was a 6% increase in the price of a new car. That would seem something that could happen, right? The old price, the original price, was $17,465. What was the new price? You're going to start by writing old, change, new. You're going to put a dollar sign on the right side, a percentage sign on the left side, and I've provided that with you, your notes. We're always going to put 100 in the percent next to old. And does everyone see that in the notes? We're going to use this model the rest of the semester. It's not going to go away. How much was the percent of change? 6%, yes. So under change, under percent, we put 6. Does that make sense? Is this an increase or a decrease? Did the price of the car go up? Did the price of the car go down?
Up.
It went up, thank you. So we're going to say the change is addition. We're also going to then say the percent that the new car is of the old car is 106% of the price. Does everyone see where I'm coming up with 106 on the left-hand side of that model? Okay. I also was given in my example here the fact that the price of the original price, the price that we're going to call old, was $17,465. So in the right-hand column where I'm putting dollars, I want to put $17,465. Is everyone with us, or does someone have a question? What do I want to solve for? What am I asked for? The new price. Good. I'm going to switch papers here for a minute because I'm going to do this one together with you. You should have a piece of paper that looks like that. Does that make sense where we came up with every number? We haven't done anything but read the problem, fill in the model with the appropriate numbers. We were actually asked to find new, so I'm going to put an X right there by new. And we're going to talk a minute about the word proportion. We're going to leave this for just a minute and talk about what proportions are. In 2-3, we solved problems using proportions. By definition, a proportion is two fractions that are set equal to each other. Remember, we had a numerator and a denominator on the left-hand side. We had a numerator and a denominator on the right-hand side. And we solve proportions by cross-multiplying. We take the numerator on the left times the denominator on the right. We take the numerator on the right times the denominator on the left. We set them equal, and we divide by whatever's in front of the unknown. We are going to solve this problem using proportions also. The trick is we've got too many numbers. I've got 3 numbers on the left and 3 numbers on the right. There's one of these lines I can completely ignore. I can ignore change. I had to have it. I had to have it to set my model up. But I can actually draw a line through that. This is the problem I'm actually going to solve. I had 100% of the price. It increased and became 106%. That 100 is to 106, like 17,465 is to what number? For every $100 of original cost, the new price of that car is $106. The original price was $17,465. The new price is what? We're going to cross multiply. I'm going to go 100 times X equal 106 times, whoops, 17,465. How I solve that is I then divide by 100. Should be able to put that in your calculator. What does someone think the price of the new car is? Real loud.
$18,512.90.
Thank you. $18,512.90. Who's lost and who's got it? Questions?
You just don't multiply it by 0.06.
Yeah. That is one way of doing it. But we are going to do many other topics where we're going, and what we're going to do is set every topic up with proportions. Throughout the book, we're going to address many different topics. And in every topic, we can solve them with proportions. If you solve this that way, you've got to memorize the model for doing this percent increase. Then when we do other things, you're going to also have to have other models, and this one model will work throughout the entire semester. And you're saying, I know another way to do this. And lots of you do. But this really is a very powerful model that will help you see all the pieces of the puzzle. As we get into later chapters, we're just going to keep doing this. And I think that you will be very comfortable with everything we do if you let yourself get comfortable with this particular method now. What she wanted to do was take 0.06, which is the change, times the 17,465, figure out what amount of change there was, plug it in here and add. Isn't that what you were thinking to do? And actually, and I will tell you that, let me do one other thing here. These are great questions. It's going to take me a minute to set this up. If someone asked what the amount of the change was, we could draw a line here and say for every $100, the change was, I need to scoot this, the change was 6. And that would calculate change for me. When we have the 3 lines of the model set up, we can take any 2 of them, draw a line through the 3rd one, and calculate. If the question was, what is the change? You could do the change. I encourage you to follow this model simply because there will be things later on that probably aren't part of your prior knowledge. And it'll be hard to explain how to do all of those different things, different ways, when we're going to use this one technique the whole semester. Are we okay with that one? And do you understand that if I was looking for change, I would use the first 2 rows? If I'm looking for the new, I ignore the middle and use the top and the bottom rows of the 3? Great. Okay, let me flip pages here. We're going to go to example 2. Find the new price after the given percent of increase or decrease. What we want to make sure we do is when it's an increase, we add. When it's a decrease, we subtract. Yes? $2,000 is my original amount. I've got a 55% increase. I want to know the new price. Okay? Wish this was the stock market and I owned $2,000 worth of this stock and it increased by 55%. Wouldn't that be great? Okay, here we go. We're going to do old change new, percent, value, 100 always begins there by the old. Start every problem that way. I like to do the percents first. What's the percent of increase? 55%. Great. Am I adding or subtracting? It went up, so that's an add. 155 is what's happening there, right? Old price, $2,000. What we want to find out is new value, right? We can ignore the middle. Although we had to write it down because that's how we came up with the 55 to add to the 100 to get 155. Now we're going to set up this proportion. Is making sense, Quincy? Yeah. You've got that look. Like, what is she doing?
What is she going to do?
That's right. Do you know what I'm going to do next?
I think you're going to cross multiply.
I am. I like to go ahead and write it down as a proportion instead of working it directly from there. But you're right, then I'm going to solve it by cross multiplying. I'm going to write 100 became for every $100 of value. The new value is 155. That's the meaning of 100% became 155%. 2,000. Is that all right? Cross multiply. Then I'm going to divide by the 100. At this point, you should be able to enter this into your calculator directly. You should just be able to take 2,000 times 155 divided by 100. You can go ahead and do the math, not needing to make but one entry into your calculator. If you want to do more than that and you're more comfortable with it, but I personally like to just get it to that point, put it in my calculator, get the answer. What did we come up with? If this was $2,000 worth of stock that had gone up 55%, how much money are we going to have now? $3,100. Very good. That's what I got when I was doing this at home before I got here. Next problem. I had something that was valued at $159, and I've had a 66% decrease in the value of that item. Let's set it up and see how it works. I'll let you work quietly while I set it up on the screen here, and you can be watching what we do. Set it up with old, change, new. Write the model down originally. Change this time is negative. Move this sheet of paper. What are we going to put under the column new and percent? How many? 54. You have a calculator? Did you get 100 here? 66, huh?
34.
34, great. I'm looking for new value. The X goes here. I'm going to ignore the middle. Somebody back there, how are you doing? Fran?
5406.
5406. If there was money involved there and there needed to be some rounding, we'd round up. Is that one making sense? Okay. We're just going to keep working through these problems, and then there's about 3 more examples, and then we're going to do some applications where we're really going to put some words on this and bring them into a business sense, okay? Does anyone have any questions about the model itself and what we're doing? Next example says, I've started out with an original amount of $275. I've had a 3.25% increase. Do we expect the new number to be lots bigger or smaller, or just a little bit bigger or smaller? Little bit. Is it going to be bigger or smaller? A little bit bigger. That's right. This is an increase of only 3.25, which says for every $100 of original evaluation, it's only gone up $3.25. That's the meaning of percent. The number that we're looking for is going to be not much larger than the 275. Once again, we're going to cross multiply. These proportions are very, very, very powerful. We're going to work many topics using proportions. Once you've got the proportion set up, it should just become very mechanical about how you do them. Someone help me, who's got an answer? 283, they're telling me, point. They're saying round it to 94. So no one's lost. Everyone's on target. That's the plan. Great. In each case, we were looking for a new value there. Now I've got a twist. We're going to know what the new value is, know how much the decrease was, and we're going to be looking for the original value. Okay? I want to know if the new value of something is $200 and it just decreased by 10%. What was it worth before that decrease? Okay? Same model. I'm writing sloppy. I'm going to flip it around and do better. I'm always going to begin by putting 100 next to old. The change was a 10% decrease, so the new is a 90%. I also, in this information, know that the new value is 200. So next to the new under value, under dollars, I'm going to put the 200. I'm actually looking for the original amount. So the X goes under the dollar sign next to old. Does everyone see how this problem differs when you read it and differs in the setup? I was given new. I'm going to calculate old. Proportion is going to be 90 over 100 is equal to X over 200. I'm looking for old.
This is up there, 100 over 90.
Mm-hmm.
That's what I got off.
Yes? Did I say that wrong?
Yeah.
I'm sorry. I'm thinking and reading at the same time. 100 over 90. And I can zoom in on that. For every $100 of original evaluation, after a 10% decrease, it's worth $90. A 100% became 90%. The old value went down to 200. Ask me your question.
To me?
Mm-hmm.
Oh, it was just, well, I got 100 over 90 and you said 90
I said the
over-
wrong thing. Okay. But now, did it work out for you?
Yeah.
Okay. Okay. Ready for the next problem? Has everyone ended up with $222.22? And that would make sense. The value of this item was more. It's gone down, and it's gone down to 200. We should have had a number that was larger than 200. B. I've got a new value of $1,785. That new value represents a decrease of 22% from the original amount. Let's see if we can get it set up. Am I adding or subtracting in the percents? It's an increase. Is that all right? I'm going to ignore the middle. Cross multiply. This time we're going to have 122x equal 100 times 1785. Divide by 122. Divide by 122. Is that all right? Should the number that I get up here for x be bigger than 1785 or smaller than 1785? Smaller. Very good. And it should be, because it represents, the new represents an increase, right, from the old number. I got $1,463.11. Any questions in general about the model that we're using? If someone was asking you to give them the change, and you had the old and information about the change, you realize you could just draw a line through new and come up with the amount of change by using that same proportion. Okay. All right, let's look at some applications then. I'm going to flip a page up here. We're in business. It's not been a good year. There was a 20% drop in sales from last year. This year's sales are $125,000. How much were last year's sales? What have I got and what am I looking for? Have I got old looking for new? Have I got new looking for old? You've got, what'd you tell me? We've got new, we're looking for old. I sound like a broken record, but we're always going to set these up exactly the same way. We're going to start out by going old, change, new. Old percent is always 100. We know that the sales decreased, so the change is negative, and we know they decreased by 20%. So what percent are we going to put next to new? 80. Very good. I also know that this year's sales, which would be under new, are $125,000. I'm looking for last year's sales. Once I've got all of the columns lined up properly, I can use any two of those to solve the problem. No one's asking me about change, so that's the one I'm going to ignore. Is that all right? I'm going to then set this up as 100 is to 80. Is that all right? Does this make sense? Okay. Quincy, tell me what we're going to do. I'm asking you because I know you know.
We're going to take 120, well, we're going to cross multiply.
Cross multiply, that's right.
And we're going to get 80x equals 112,500,000.
And you don't even have to make that calculation.
Okay,
You can just do 80x equal, I know what you're doing. You were going ahead and multiplying out this number.
Okay.
Don't even need to do that, although you're welcome to.
Okay. I don't know what x equals. I don't have a calculator.
Okay, oh, I'm sorry. Somebody else that's got a calculator have it figured out?
15,625. Or is it 156,000? 156,000.
He's saying 156,250. And let's take your 15,000. I know you did. I know, but I just want to estimate. If there's been a decrease, and this year's sales are 125,000, and that represents a decrease, do you see that it couldn't be 15,000 just by estimation? Sure. And he's got a very small display on his calculator, and I think it's not a problem. I just want to point out that I knew before I looked that the 15,000 couldn't be right. I knew that the number I was looking for was larger than. And I like to think about the kind of numbers I'm expecting so I know whether or not the answer's logical. So the 156 seems logical to me. Fran, did you have a question? I thought I saw a hand back there. How's everyone doing?
I wish the first three chapters were this easy to understand.
And that has to do with, and that was a very nice comment, that has to do with some of your prior learning. You know, you maybe came in handling percents in your life sometimes, and maybe those decimals aren't part of what you've handled on a regular basis. Great. And it makes sense the way we set it up to you. Good. All right, new problem. Let me get out another blank sheet of paper. This one's a little bit different, but I think we can work it together. You have to pay a little bit more attention to this one. It's a little bit different than we've done before. The current sales tax rate in a city is 6.4%. Zoom down on this. And the city actually intends to raise the tax rate by 25%. Taxes are going up in this city. How much will the new rate be? We're dealing with percentages on both sides of the model. Is that okay? Is that making sense what we're doing? So let me start out by going old, change, new. I'm going to put percents on this side. And over here, I'm just going to call this side value. The old percent is always 100. How much am I going to increase taxes by? 25. This is a plus, yes? So this becomes 125. What's the value of the taxes currently? Good. So instead of putting money over here, I can give you a tax rate of 6.4. The tax rate is going up. The value that you pay in taxes is going up. Is that making sense? We're looking for the new tax rate. Sometimes what's in that dollar column represents a value other than dollars. The original value is always represented by 100%. The change is 25%. The new value of the taxes is 125% of the old taxes. I'm looking for this number right here. I'm going to ignore change. We're going to do the set it up as a proportion, cross multiply, get into the mechanical part of just doing it. For every $100 that you paid in taxes, next you're going to pay 125. If the rate was 6.4, I need to know what the new tax rate is. That should feel proportional when you set it up. Feel sort of a sense of balance with it. Once I cross multiply, I get 100x equal 125 times 6.4. I'm then going to divide by 100. Divide by 100, x equal 8%. So that doesn't represent a dollar amount, it represents a new tax rate value. So that's a use for this old change new that doesn't have to do with possibly retailing or money. Okay, one last problem. Then we'll start our homework. We're going to have the reduced price of an item is $45. So you're wandering around the store and you find out that something's been marked down and the new price is $45. The sign up above says you just saved 35% on this item. And you say, wow, I wonder how much it was before it got marked down. I'm given the new price. I'm given the amount of change. I've given that the change has been a decrease. And what I want to know is, how much was it before they marked it down? Can you set that one up? What am I actually looking for? Old, that's right. Once again, we start with the model that says 100 goes on the percent side next to old. Let's work down the percent sign together. Was this an increase or a decrease? It was a decrease of 35%. What percent then do we put in the new column? 65. For every $100 that the old item would have cost, the sale price is $65. It really means we're paying 65% of what the original price was. The new price is $45. I'm looking for old. Yes? Set it up like a proportion and cross multiply. $100 is to 65, proportionally the same as X is to 45. I got $69.20. I've got very bad handwriting. 23 cents was the original amount. Okay. Are there any topics in today's lesson that we need to go over? Any of these problems that don't make sense? Good. Then we're going to conclude by turning off the tape and letting each of you get started on your homework, and I'll come around and see how I can help you.